Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this.
We spent a lot of time in this lesson learning how to do some calculations, and it's very important to learn how to do those things. Now I'm going to show you some tricks where you don't need to use calculations, and you can do this by some simple measuring. The things that you need is a 90-degree angle, like on some sheetrock or some plywood that you have on the job if it's available. These give you the answers very quickly without calculating. Now the reason I hesitate to teach these things initially to a new student is sometimes they mix up the tricks and they use part of one trick and part of another trick, and they get an answer that doesn't work and they wonder what they did wrong. But if you know how to do the calculations first, then you'll keep these tricks straight. And another thing, you're not always going to be able to use these tricks because you may not have a right angle that you can measure off of. And sometimes it's real easy just to do the math in your head. I tend to be pretty good at mathematics, and I can just do some of the calculations in my head very quickly. Almost right after I'm done measuring, I know what the shrinkage is, and I can just do all that in my head. But I'm going to show you some things anyway. A lot of people find these tricks very helpful. I use these tricks myself, especially when I have to do offsets and I have fractions. These are very helpful. I mean, you can carry fractions out in a calculator and all those decimal places calculated easily. But this is a very helpful and a very quick way to get some measurements. So I'm going to show you these tricks right now. So let's get to it. Here's a very simple example that we've already looked at in this video. We had an offset that was 8 inches in depth, and we wanted to make a 30-degree angle. Well, we have a straight line with this plywood and a corner here, so let's mark 8 inches. Now, when we used a 30-degree angle, the distance between our marks was 2 times 8, or 16 inches. So, in other words, if we were coming off of this straight surface here and bent it at a 30-degree angle, 16 inches would be where we would bend it, because that's the distance between the marks, and that gives us our 8-inch offset. Okay, well, let's look at something right here. If we go from this mark now 16 inches this way, okay, we're at 2 inches right here. Now, remember what our shrinkage was? It was 1/4 of an inch for every inch of depth, and 8/4 of an inch is 2 inches. So that's 2 inches of shrinkage. And that makes logical sense, because if the pipe here is 16 inches after it's bent, well, when it's straight, when it's straight and comes down here, there's our 2 inches of shrinkage. So you can see how it shrinks back 2 inches. So that's a very simple way that we could find out what our shrinkage would be there. Now, here's another example and how we can use this trick. Remember when we did our rolling offset, our numbers were 7 inches, so let's go up here, 7 inches. And 11.5. So let's do that. And we had to get that diagonal. Well, instead of using the Pythagorean theorem, it's the same as drawing it out. And we have here, if you can see, as you're looking at the camera, we came out to 13.5 inches when we calculated it. And when we measure it, we come out to 13.5 inches. Okay, what if you're using 45-degree angles? Well, here's something very simple. On a 45-degree angle, both sides of the triangle are the same degree. In other words, let's do a simple one here, 10 degrees or 10 inches. So if we come up 10 inches, And if this would be a 45-degree angle, well, this distance away is also 10 inches. Okay? So if we measure, now our multiplier is 1.41, so we should come up with 14.1, or about 14 1/8 inches, right? And if we look at this right here, we're right at 14 1/8 inches, maybe a little bigger here, but again, we account for the thickness of our marks and the accuracy of our measurement, so again, always measure precisely. Okay, now let's try this. 14.1, okay, from 10, so if we go this way, of course, or 14.1, we would have 4 inches on our shrinkage. Okay, now the shrinkage is 3/8 of an inch on a 45-degree bend. 10 times 3/8 is 30/8 of an inch. Okay, now 32/8 of an inch is equal to 4. So here we are here, and we're showing actually just a little bit less than 4. We had 32/8, which would be 3 3/4. So we're right in there. So you can see we have our shrinkage right there. And again, it's the same thing. We take our distance between our marks after the bend, and if that conduit was straight, the shrinkage would be the distance from where we want to start the bend to where the actual obstacle that we have to offset over is. Let's look at another example here. Suppose we're 20 inches away from our corner, so we already have that marked, and we're 8 inches up is what we need a kick. Well, if we use this trick that we've been doing, we find we're at 21 5/8, which means if we come down here, we're 1 5/8 away. Now suppose we had a situation where there was an obstacle right here, and that's why we had to make our kick back here, and it had to be this high. And at the end of our kick, we had a 90 that had to come up like this, and it had to kick up that 8 inches, and the back of the 90 had to be right here, which was 20 inches away from the start of the kick at this obstacle. Okay? With what we just learned, remember this distance across, which would be the distance between the marks, was 21 5/8. Now, of course, there's going to be some shrinkage here, and this would be an odd angle. Now, we could use the cosecant table, but what we could do instead, we measure, here's our fixed point, we measure from where we start our bend up to this fixed point, and then we're going to add 21 5/8 of an inch. And then from here, we could use the back-to-back technique for bending a 90-degree angle. And then we could make our kick, mark it back from the back of that 90, our 21 5/8, and then when we make our kick, what happens, it comes up like this, bends up of course, and we would be 8 inches, would be the height, and it would shrink that 1 5/8. So again, with a non-standard angle, this becomes a very useful trick, and you can use it with kicks and with 90s and things like that. So once you start using these techniques, it's easy to start combining them with the things that you already know, and you can bend a wide variety of angles, and they're very useful to help you in difficult situations. So be creative in what you're doing, think it through, and if you need to, use the calculations. Here we are at the end of the second segment of this lesson on how to bend conduit with a hand bender. And again, this second segment, it's some new things that we've added and revised, and we've combined what used to be the advanced lesson into this lesson, because we felt, and a lot of our students felt the same way, that they should have all this information at one time. So instead of making it two separate lessons, we've decided to combine it and enhance it and make it even better. So you've learned some tricks. You've learned also that the tricks that we've taught you are mathematically sound. They do work, and with the calculations, we've shown you how to use some calculations that may be a little bit different than what you're used to. But I feel that with what you have now and what you've learned in the first installment of this lesson, and now with what we've added with that, that if you apply yourself, you're going to become a very proficient and skilled craftsman and be able to bend conduit very well. So once again, we thank you for participating with us in another one of our lessons, and we look forward to seeing you somewhere in the future at one of our other lessons. Thank you very much for watching.
Thank you for watching this video. Please click on the like and subscribe buttons so that I can continue to make more videos like this. If you find this video helpful, please consider donating using the PayPal link below. Thank you.